All right. Boy, I should probably put this on so you can hear me better. So we have to learn about the derivatives of inverse trig functions. First of all, I want to talk about a couple of things. Here's the unit circle. Remember, with the regular trig functions, like if you find the sine of pi over 4, it's right here in the unit circle, right? Oops. The pi over 4 radians, right? And the coordinates of that point are square root of 2 over 2, square root of 2 over 2, where the x is cosine and the y is sine. So the sine of pi over 4 is the square root of 2 over 2. With a regular trig function, you put in a radian measure or an angle measure, and you get out a number, which is a ratio of two sides of a triangle, right? Inverse trig functions you put in a number and you get out a radian measure. So the value of this whole inverse trig function is a theta. It is an angle measure. Okay? Inverse trig functions are thetas. The numbers you put into an inverse trig function have to be in between -1 and 1. Right? So when you're using inverse trig functions, you use quadrants for sine. You use quadrants 1 and 4. Because y values have positive values and negative values in those two quadrants. For cosine, though, with inverse trig functions, you use quadrants 1 and 2. Because those quadrants have positive x values and positive x values and negative x values. And for 1 and 4, for sine, since it's above the x-axis, they have positive values, and below the x-axis is negative values. Right? The other ones that go with sine are the reciprocal of sine, which is cosecant, and tangent, which is sine over cosine. The other ones that go with 1 and 2 are secant, which is the reciprocal of cosine, and cotangent, which is cosine over sine. Now, there are some formulas, and all you have to do is memorize 3 easy formulas, and you'll be able to take the derivatives of inverse trig functions. Like the derivative of inverse sine of theta is d theta now let's change that. Let's use u, because u can stand for a function. Theta just stands for a number. The derivative of the sine of u is du dx over the square root of 1 minus u squared. So whatever's here, you just square it and put it here. Whatever's there, you take the derivative and put it there, and then everything else is just filling in a formula. For cosine, if we take the derivative of inverse cosine, it's just negative du dx over the square root of 1 minus u squared. I'm going to just do tangent, but cotangent is the negative version, and I'm going to just do secant, and cosecant is the negative version. Okay? So tangent, arctangent, or inverse tangent, its derivative is du dx over 1 plus u squared, no square root, or u squared plus 1, right? for secant, arcsecant, inverse secant of u, it's du dx over a couple of things, absolute value of u, and then the square root of 1 minus u squared minus 1. Sine is 1 minus u squared. Secant is u squared minus 1. Okay, so those three formulas are the ones you need for sine. Cosine is the same thing, but it's negative. Tangent. Cotangent is the same thing, but it's negative. And arcsecant, when you take the derivative of our cosecant, it's exactly the same except for it's negative. Okay? There are some problems to do, and I've got another video of me answering questions from those problems, so maybe take 10 minutes and try some of the problems for homework. I could probably give you the assignment. What is it? It is page 175, 1 through 21 odd. And then the other video, the one that's marked 10/13, today's date, is a video of me answering questions from that exact assignment. So anyway, good luck.